This morning's session is Bernard Guy from Mines Saint-Étienne Institute 9's Telecom, France.
Okay.
Professor Guy.
Thank you. Well, so I'm going to present you my way of looking at the links between natural and social sciences. I am not a specialist on the subject, and I will only give you some very general remarks in relation to my way of understanding thermodynamics, and also in relation to my way of understanding the concepts of time and space. Again, like I told yesterday, this will look rather philosophical, maybe with not enough equations, but I think it is necessary to renew our understanding before we have a new look at the equations. So consider these are lines of research, a framework for future work. Well, the subject is huge, and there has already been a very large number of contributions to the topic. On this slide, I have listed the names of a few authors, among many others, who have contributed to the topic and whom I know a little about. Well, I am myself interested, among many other topics, by the understanding of different levels of social reality. And I think that thermodynamics tries to connect different levels of physical reality, from microscopic to macroscopic. Social reality itself is manifested from the level of small groups of people to the level of countries and continents. With Emile Durkheim, I am wondering whether there is an autonomy of social facts with respect to the psychology of individuals. While Auguste Comte and his positivism discusses the hierarchy of sciences from mathematics, astronomy, and physics to what he calls social physics. Well, yesterday we heard Lib Thims, who discussed about the contribution of Auguste Comte. I am also interested by the works of French mathematician René Thom, who stresses the importance of what he calls the qualitative morphology of natural systems. Well, these are the main lines of my talk. I shall begin with general considerations of an epistemological nature on models in science, both in physics and in the human and social sciences. I will then focus on my understanding of thermodynamics, and I will then present some consequences according to me on the relations between thermodynamics and social sciences. So let us start our first part. Well, actually, I have not so much time, and I will skip a few slides. This slide about models, what is the purpose of a model. I will also skip the next one, what I call degrees of modeling. And I will also skip the next slide about the different ways to connect scientific disciplines. But we may make a stop on what I call the recursivity. It is called the recursivity type links between different disciplines. This means that one discipline needs an input from a second discipline, and the second one also needs inputs from the first. This is understood within a relation-based rationality as composed with more substance-based rationality. Well, Professor Steve Keen discussed in a way this topic. It is the issue of connecting micro to macro or macro to micro. And the second point I would like to stress is that in order to make the disciplines work properly, we need an exterior to the disciplines from which our conventions are founded. There are no universal laws as dictated by reality. We always need conventions of social nature, for instance, in the choice of standards. Well, these two characters, the recursivity and the existence of an exterior, are related to my way of understanding the trilogy space-time movement, and we will find them also in thermodynamics. Well, I also skipped this slide that discusses the comparisons of the models in the natural and social sciences. Well, yesterday we also heard about the so-called two cultures. So we have finished our first part. Here is what we need to remember for the rest of the talk in our aim to link thermodynamics and social sciences. Well, you can read a few points, but I did not discuss the difference between explain and, this is more for social sciences, and predict, rather for natural sciences, and the reflexivity problems we are finding in the social sciences. It is important in the social sciences. In other words, if a prediction is announced, the announcement itself will change the behavior of social agents. This is why the word prediction has a very different meaning in both fields, and well, perhaps we should not use the same word. Well, we now turn to our second part, which is itself made of two parts. First, my way of understanding space, time, and movement, and then going back to thermodynamics. Well, yesterday I already talked about this understanding of the concepts of time and space. Well, this is a slightly different way to present it. You see on this figure, a one-dimensional model world is presented, in which three material points are shown. 2 points 1 and 2, supposedly fixed, marking space, and whose distance can serve as a ruler, and 1.3 moving from 1 to 2, marking time, and which can serve as a clock with constant speed. Well, I will not go into detail. I go right to the conclusion. It is important to note that one cannot think independently the constant immobility of points 1 and 2 at the ends of the ruler and the constant mobility of clock point 3. The conceptual circle is inevitable. In the endless regression that invites us to rely on other points to judge the mobility or fixity of the points we are studying, we must pragmatically mark a stop by defining a standard movement. This is what we are doing with the second postulate of relativity theory. The choice of a standard is of social nature, external to the physical system. In short, we promote an understanding of the trilogy of time-space movement, where movement is prior to space and time. Movement engenders space as the amplitude of movement and time as the process of movement. By considering a material point, we have frozen the world at a lower scale, but we can envisage a nested hierarchy of systems that corresponds to a hierarchy of space and time scales. There are different ways to decide the border between space and time. Well, this vision of the relationship between space and time has many consequences in thermodynamics. I will merely list them very quickly. We may stress the natural arising of entropy and its probabilistic meaning. When we decide to freeze the system at a lower scale, we freeze its configuration in the most probable state. So entropy and its probabilistic meaning naturally arises. After entropy, internal energy and heat transfer are the new physical quantities in thermodynamics with respect to mechanics. Well, I will also skip this slide and going to the next one. Without showing you all the intermediates of reasoning, I will say that the foregoing allows me to understand a hierarchical structure of thermodynamics. Well, this hierarchical structure already has been discussed by some authors, but I insist to say that it contains this understanding of space and time. One ignores or decides to ignore movements on a lower scale. One freezes in space what is time and movement on a lower scale. And also I will stress that there is no end in the sense of micro or macro. We can define laws and coefficients at each scale. Well, for instance, Newton's law at one scale, fixed, or Fourier laws at another scale. And these laws are different. I think we could speak alternatively of a hierarchy of thermodynamics. Connecting different levels of this scale. On this slide, I stress the importance of the recursivity aspect that also plays in thermodynamics, and also the role of conventions of external nature. So we have finished our second part. So when we will be interested in the social sciences and use the thermodynamics to help this understanding, we can look for a hierarchy of scales, laws of passage from one scale to another, the definition of certain new functions, such as entropy and internal energy. We'll also look for micro, macro recursivities, external inputs. Well, we could also take all the detailed consequences we have listed and adapt them to social sciences, but I will not do it now. So we now turn to the third part and to the social sciences. We will focus on two issues and discuss, at least qualitatively, the search for an entropy in some social sciences, and then discuss, still qualitatively, the question of internal energy, heat and work for social sciences. Entropy and internal energy are the two physical quantities proper to thermodynamics. Well, the first step of the thermodynamic inspiration is to place ourselves in front of a hierarchy of scales for social groups. Here you find both a hierarchy of social groups and a hierarchy of scientific disciplines, more or less related to these levels. I would say that there is no social level nor no individual level per se, but only relative to each other. The question is then to understand the passage from one level to another level of this hierarchy. We may want to move from one level to another level in order to understand how an individual opinion manifests itself into a collective opinion, or to see how a characteristic of a small social group, for instance, its wealth or its poverty, is measured quantitatively from one level to another. For instance, we want to define the wealth of a city, of a country, in terms of the wealth of a family. The connection between the levels will be used to define a policy, maybe, for instance, in relation to the question of wealth and poverty. But the wealth of the same family can vary over time. What value to take? Opinions also can vary, etc. This is where there are possible choices taking an average, taking the most probable value according to weighting choice that can be discussed over what range of time, over what range of space, and so on. And
There are
different
5 minutes
policies.
left.
Pardon?
5 minutes left.
5 minutes. Okay, thank you.
Welcome.
And in this approach, this approach can give meaning to what we could call social entropy. We can give several expressions according to the different levels. We can define different laws of behavior according to the different levels. Well, in the previous slide, we did not discuss about the macro recursivities. The transfer of understanding may operate in both directions, in the ascending or descending direction. And there are also conventions of external origin that are necessary. One cannot do without principles of, I would say, metaphysical nature. For example, we can say there must be equality among the people, or we must support the weakest, there must be fraternity, and so on. Well, yesterday, Pierluigi Gentili spoke about the bioethical issues that are necessary to take into account. Well, I am giving you just a general framework which can help us to put some order into a specific and more quantitative research that can be undertaken. Well, after the entropy, one can also think about the question of an internal energy for larger social groups based on a lower scale internal energy for smaller groups. On this slide, I have shown the large group as a giant. It represents a collection of individuals at the lower scale. This giant can perform a work in the physical meaning, Wn, with a heat loss, Qn. The internal energy variation is delta Un. And if one seeks to relate the internal energy Un to the internal energy at a lower level, Un minus 1, one must add to this internal energy the kinetic and potential energy at this level that contribute to the definition of UN. Well, this potential energy is a way of understanding the relation between people which can increase their motivation, their desire, their ability to perform such or such work. This is expressed by relation up there. These are the kinds of considerations we can make when discussing social internal energy. All things being equal, it is possible, depending on the cases, that when people collaborate, the internal energy expenditure of each may be less than the expenditure for the same total work, but each working for himself. Well, together we can. I thank you for your attention.
Bernard, can I ask you one question? What gave you the inspiration for this talk, or the general seed for the idea?
Well, I think that my research about relational rationality, I don't know if this has a meaning for you, relational rationality as composed with more substantial rationality. When we are facing the world, we cannot go outside the world to think of it and to give words to the world. And so we can only compare things to the other things. And I think this is important that in science itself, we have this type of reasoning. This maybe, and so of course the matter of time and space and so on, it is related to this thinking. But now I see that in many areas of physics and science, you must have this approach. I do not mean that you have only relational rationality, because a relational rationality is not stable. You must stop it by defining standards. But when you are aware that you have stopped something, it gives you an interesting opening to what we are doing in physics.
Thank you.
Professor Guy, I don't see you talking about conservations in your discussion there, but I assume that conservations of mass and energy are all throughout all of this.
Yes, yes, yes. Well, I did not pronounce the word conservation. Yes, you are right. But well, yes, it is written somewhere. I think that when I spoke the internal energy, when you define the internal energy in thermodynamics, you need the conservation of energy. You are adding a new energy, but you need the conservation of energy to define this internal energy. It is somewhere, I don't where.
So the session, your time is up, unfortunately.
The time is okay, so I will just wait. Well, yes, can you read this? Internal energy and heat transfer derived from the word is balance, from the energy balance. Okay, but yes, of course, it is conservation.
Yes. Okay. Thank you so much.
Thank
I
you.
enjoyed this.
Thank you. Bye.